So hello everyone, in this video I will walk you through through assignment 2 where we implemented the multi-class classification using the famous iris dataset. Okay, so basically the step in our so the first step in our assignment is to load the iris dataset from an SSV file. Since we are using Google Colab, we first upload dataset to our Google Drive and then mount to the drive to access the file, right? There are some important necessary libraries, and then we're just to print first 5 rows and then we'll keep going to label encoder here. So as you can see here, the species column contains categorical values set those are verse, color, and Virginica. Since neural networks work with numerical data, we need to convert these strings labeled into integers, right? And I keep going. And then we split data sets into input filters X and the label Y. The first 4 columns represent the filters, while the last column is in our target label. And then we're going to the here. So we split the data set into training and testing sets with 80% of the data for training and 20% for testing here again. So we're going to here. So since we are dealing with a classification problem, we apply one hot encode in our labels, right? And after that we're going to do building the neural network, right? So that now we define our neural network model using TensorFlow and Keras. The model consists of 3 layers. Keep going here. So we compile our model using the RMS probe optimizer and categorical crescentrophy loss function, which is commonly used in classification tasks. So here, so then we train our model with 20 epoch and a batch size of 10. All right, you can see here. And then we're going to loss accuracy. So the final, of course, we evaluate our trained model on the test set and print the accuracy. And we repeat, so here we just repeat the training process with a smaller model that has only 10 neurons per hidden layer instead of 100. And then we like train this model with only 4 epochs and a batch size of 10, as you can see here. So we evaluate its accuracy, of course, eventually here. So we're going to the question. Specifically, you asked me to answer the in video, but before that I'm just going to talk about that part. So basically here we will experiment with different parameters such as optimizer, type, number of epochs, and batch size. So we'll change one parameter at a time and analyze and impact the model performance, right? So we're going to quickly here. So basically the question is that each one different, so we're going to explain each one. So the question 1, of course, how the number of layers hidden units impact the accuracy of our model. So in this experiment we build a deeper model with 3 hidden layers and each containing 128 neurons. So the activation function we use is ReLU, which helps in learning complex patterns, right? And the model is compiled using the ADAM optimizer, and we use categorical crescentrophy as a loss function since this is a multi-class classification problem. So basically train a model for 20 epoch using a batch size of 10 again, and then of course after training we evaluate the model on the test sets, right? So do we always suffer from overfitting? The test if overfitting happens in every scenario. So we now build a smaller model with only 10 neurons per layer and train it with February epochs, right? But overfitting doesn't always happen, right? Basically, so can we detect overfitting? Yes. So detect overfitting, I mean, by comparing training and test accuracy. Okay, so if training accuracy is significantly higher, like importantly higher than test accuracy, the model has memorized training data instead of generalizing. So we're going, how can we reduce overfitting? So introduce, so let's say so we now introduce basically here dropout and LG regularization. So two techniques that helps improve generalization, right? The one of the dropout, another one LG regularization. So dropout randomly ignores 50% of neurons during training. So preventing the model from memorizing patterns, right? But let's say LG regularization adds a small penalty to large weights, forcing the model to be less complex. So basically we did here, so you can see compile and train this regularization model, and of course evaluate the accuracy of our regularized model. I'm so sorry. So the basically this is for assignment 2. Thank you for your time. Thank you for watching me. Happy Family Day. Take care.